Hi, everyone. Thank you so much for joining us today. We will be discussing supply chain visibility and optimization today using graph and machine learning. I just want to remind you that this webinar will be recorded and sent out to all of you afterwards. If you have any questions, go ahead and save those till the end or post them in the Q&A box at the bottom of your screen, and we will have time to answer those at the end of the webinar. I'll go ahead and hand it over to Scott.
Hello, everyone. We have on tap for you today a couple of in-depth subjects inside of supply chain, as well as a couple of demonstrations. And without further ado, for those of you who've come to our webinar series previously, my name is Scott Heath. I'll be one of our tour guides today. And with me is Graham. Go ahead.
Hey, everybody. I'm Graham Gansel. I am a data scientist here at Expiro, and I'll be taking you through the technical section of today's webinar.
Fantastic. For those of you who don't know Expiro, we are a software and consulting company. So the things that we're going to show you today are part of our toolkit, some of the industry technologies with third parties and open source tools. And we specialize in technology solving these problems. A couple of different categories. Obviously, today we're going to talk about supply chain, but we also work in several other categories. And one of the things that we're going to see today is that rollover or capability in that supply chain. The other thing is we do a lot of different categories as well as industries. And as we see here, several large customers with big problems. And that's one of the things we're going to share today then is some insight into how we solve some of these bigger enterprise business problems. Well, that gets us right to the point. And that is then supply chain and specifically in visibility. With this slide, as we can see in the background, one of our favorite ocean liners is that the electrical systems are doing great. Check. The deck systems are looking good. Fuel systems, oil, and safety. But gosh, what's the one thing we missed? And that is the iceberg. And that's really what we're trying to get across here in this slide is that really, which brings us to our supply chain, the capability of being able to see what's underneath, what's ahead, and effectively what's that return on investment with what we're doing in supply chain. With that, let's talk a little bit about the process. And those of us who are familiar with supply chain, and each of us are slightly different, whether you're in retail, airplane manufacturing, automotive, or whatever your category is. But ultimately, it's a progression. We start with source materials on the left, ingredients. We manufacture or assemble those with bills of materials. We move to inventories where those are located, warehouses, and then finally, we look for logistics. How do we transport them? And then ultimately, our customer. These start to potentially break down into silos, different systems over time. And that's one of the things that we see in supply chain is historically, where did these come from? But how do we now sort of elevate? How do we avoid that iceberg, if you will? And that's where we start to see these different categories, whether it's supply planning, managing each of these different components, but ultimately now this ability to separate, identify how to see and visualize that a human being can actually take actions, and then perhaps using machine learning and what we're going to see today then is the graph technology and combined with machine learning and visibility is how do we ultimately get that human in the loop? How do we do things perhaps that are automated to create this return on investment and solve bigger business problems because we'd like to, as funny as it is, avoid that iceberg. And specifically then that brings us to what's below. What are those elements now that makes our life hard? And it's this consistently large sets of data, this concentration of data in multiple different disconnected systems, this capability now to understand that bills of materials have dependencies. They also have dependencies on shipping, logistics, and timing, as well as moving to customers and then identifying alternatives. That alternative capability now doing it in near time, real time, overcoming perhaps what may be our current infrastructure of batch technology, but now sort of bringing it home, which is putting it into bite-sized informational visuals or creating data that humans can actually interact with and create solutions or solve the problems, as opposed to running reports at the end of a cycle and saying, gosh, it would have been great if we could have made that change. But these are some of the things that are now below that waterline, if you will. So now when we look at these large silos of data, this could be in your SAP system, this could be in your Oracle system, your homegrown ERP system, it could be all of those things. And typically what we see is this spreadsheet mentality, which is those systems didn't do quite what I needed. I'll go ahead and put it into my own Access database or spreadsheet. And now we have yet another splintered data silo. But the problem is this continues to happen, and more importantly now we have years of historical data where there is no sort of source of the truth or golden record, and it becomes now more and more fragmented as we look across multinational kinds of supply chains. This endless dependency, which is if I move this and I break that, what happens if? This capability now to be able to look at this inventory, or whether it's a supply shortage, et cetera. How do I start to come up with those options? How do I start to look at what if modules? How do I start to proactively get involved in these kinds of things? And it's these dependencies that many times trip us up. Because we have those multiple source systems and now we have these dependencies, it becomes very complicated very quickly. Then I start looking at alternatives, which is if I made a change and it rippled into dependencies and I looked at these multiple systems, how can I get an answer that is truthful or percentage-wise better than perhaps what I'm doing today? How can I do these other kinds of things? And more often than not, sometimes a human, when shown different alternatives, can come up with things that in some cases machine learning hadn't thought of. But how can we start to use that human in the loop? How can we start to use things like graph and machine learning to create an even better model? And that's ultimately what we're driving towards. Okay, so now that we've set the table, let's talk a little bit about sort of how we can do things differently. And that first one that we talk about is something called graph technology. Is it a piece of yarn? Many people may see it as that. Other people have said it's a graph, it's a pie chart. No, that's not right either. Graphs are actually something that have been around for a while. The other thing that's been funny recently, which is, well, gosh, let's just let the graph do it. Well, graphs are not silver bullets, and unfortunately, graph alone is merely a new data model. It's something that's new, it's very powerful, and we'll find out what that is. But no, it does not indeed solve all the problems that we've been hoping it would do. It merely becomes a tool in our process. For those of you who don't know what graphs were originally invented in the 1700s by this gentleman, Euler. He was a mathematician, and one of the things that he started to identify was this concept of structures. Well, what are these structures? These are nodes and vertices, as we'll see here in a minute, but it's this complex web of relationships, and that's really what starts to bring rise to a different way or a different data model, which is different than a SQL data model. And at its simplest, a graph is a vertex and an edge. That is now starting to look at nodes and relationships, which are very different than what we do inside of a SQL database. And in this case, we can start to see things like, in this case, New York is connected by a railway to Boston. And these are now the DC1 and DC2. These relationships now, as we can start to model them, start to very naturally become elements that we can use in supply chain. And these concepts now of whether it's a route or it's a shipment or a bill of material are all extremely powerful. And again, a very different way of seeing things in a data model. One of our simple examples, and we've seen this in many places, is that of a social network. And all of us are probably well aware now that social networks are indeed graphs. Everything that we do, relationships that we have, whether it's business or personal, many of those different attributes are all part of this relationship or knowledge graph of an individual person in the middle. In our example, we have two different people. We have Katy Perry on the left and Barack Obama. And as we start to investigate these two folks inside of a graph from that lens, what we identified then is Katy Perry has millions of followers. She has far more than Barack Obama. However, using a graph algorithm called degree or centrality, we can start to see that, well, in fact, they are quite different. If we see the graph over on the left for Katy Perry, she has lots of unrelated graph relationships, and a few of them are related. But in fact, Barack Obama has fewer single relationships, but his are quite more influential. And so what happens in that particular graph model is we can run some algorithms, but they're very different in the way that they relate to each other. And we'll see those in some of our demonstrations. So at our simplest, now we can start to see in one case, we may have a chip on the left that is not connected to other parts or pieces and bills of materials, and the chip on the right is actually very dependent. And so part of that could perhaps be if we had a predictive outage or if we had a supply issue with the chip on the right, we can see that it actually is related to multiple subproducts and subparts, which could indeed cause a very large or complex issue inside of our supply chain. And these are the types of relationships now that we wish to harness with the graph technology. And specifically now, that's exactly our premise, which is supply chains are graphs. So things like bills of materials, things with vertices and parts, things that have edges where they're consisting of or compatible with, and then the ability to use or do analysis on those. So simply by using some graph algorithms that we'll see here in a second, I can actually query the graph and ask it what consistent parts are there, and then are there replacement parts for what those are, and then the graph can give us, in effect, the answers. The other thing that we start to see then is manufacturing and inventory, whether those are warehouses or distribution center. What are the options to get transport accomplished, get to customers in different areas? And then we can start to query that graph for things like critical path, impact analysis, and then query for things predictive perhaps of optimization, et cetera. And then finally, things like transport, railways, roadways, air cargo kinds of things. All of those transportation ones are natural graphs as well for similar styles of things. So we know where those rails and roads are. We know when things happen to those, congestion, et cetera, and we can start to look for shortest routes, best extensions, et cetera. And more importantly, one of the ones that we see is this cost optimization. What if I did one versus another? Again, the concept is to use this graph for what it's very good at. Now we start to understand what a knowledge graph is. Well, one of the great things about a graph is the more data we feed it, the smarter that it gets. Each of these branches and nodes over time, as it starts to build, the beauty of that then is the more knowledge we get, the better and more knowledgeable that we can start to query it, and our outputs start to become as it grows over time. So for instance, we may start with simple bills of material and master data. We may move later to shipping orders and purchase orders. And then ultimately, once we have that knowledge, we can start to do very advanced kinds of things that our friend Graham is going to talk to us about today. So now that we've decided that graph is good, graph can do some things for us that SQL and other kinds of structures can do, but take longer, perhaps are not as simple, et cetera. And what we see now are these graph algorithms on the left. Things like clustering, this capability to do recommendations, shortest path, connected, centrality, et cetera. And now we start to say, well, what if we use the power of machine learning? Now we can start to stand on top of this graph technology and start to really expand beyond simply doing analysis and those kinds of things. If you follow along down on the bottom, if you'd like to go out to this website, you can actually go see some of these other algorithms and you can test those yourselves and get more information on those. And then obviously with the different kinds of things on the right and the left, you can certainly investigate those on your own. But these are the premises now of where we're going with the power of graph and machine learning. Well, a lot of times customers ask us why. Why not just stick with SQL? I can do this in Tableau and I can do this in many of the other products that are out there today? And the answer is yes, you can. One of the big problems that we start to see then is doing a 32 table outer join is quite brittle and can be quite time consuming. Whereas a simple gremlin query can actually query the data structure and is quite flat. And typically we can accomplish similar kinds of things in 1 or 2 lines in gremlin that we can do. But our premise is, why not use them both? Use them for what they're good at. Perhaps OLAP transactions, your SQL kinds of things in your data lake are great. Let's leave them there. Then the next sort of element then is, let's add this graph database where we can start to do some of these more advanced analytics and those kinds of things. And that's really the key here, is use them for what they're good for. Let's take this graph structure and this new data concept and let's use it now for something different. A lot of times we're asked, which is, why is graph so special? Well, one of these quote unquote free algorithms alone and or the concept of this velocity by which we can do it is typically what people will say. So having a query time that's in the hundreds or thousands times faster, this ability to now do it in perhaps less code. But ultimately where we're going here is using graph for what it's good at, which is the relationships. And many times we can pre-derive these connections. We can start to do pattern matching. And again, many of the things that Graham is going to share with us today. And then this reflexive to these dynamic changes. So as things change, you can query the graph as opposed to a SQL data structure, which is typically you have to know approximately what the outcome is. Let's ask the graph what the shortest path is. And that's really sort of the core concept, is instead of doing this SQLing, as I call it, we actually then want the graph, as it gets more knowledgeable, to carry us forward. Okay. So with that, one of the things that we want to talk about now is the life cycle. So as we start to stand on top of this concept of a graph, we start to use things like machine learning, and then we use this concept of visualization. What is it that we're ultimately trying to do in this life cycle? And the first element then is really, let's see it. Let's try and put a finger on it. Let's identify the magnitude of this problem. Is it a single item, or is it really sort of conducive, or is there, as we hear many times our customers say, something called a bow tie, which is, if you can imagine the knot in the middle, it has sources on the left and sources on the right. It simulates a bow tie. But is it truly a knot, or is it a one-time kind of a thing? That's where the analysis really comes in, which is now potentially identifying, what is it? Where is it coming from? Where is it going to? Is there or are there costs and different kinds of scenarios? And then let's identify sort of what those potentials are. Then, as we move to optimize, which is either having a system recommend for me or a human in the loop, start to identify, how can I make changes? How can I interact in a positive way before something actually happens that's bad to my supply chain? And being able to test and elaborate on those scenarios. And then things like planners or intelligent agents now that are, again, recommending in certain times or cycles how to avoid those things. And then finally, this automation, which ultimately brings us to then whether things happen automatically. Maybe there is a human in the loop, but many of those things are actually happening automatically behind the scenes, if you will, where I don't need a human to look at, or where things are indeed more smooth, so that we can move on to spend our human capital in truly difficult scenarios versus things that are fairly straightforward. So now that we understand this visibility, what we'd like to do is give you a quick demonstration. Okay, so in our first demonstration, what we want to do now in this case is I'm going to show a life cycle of a computer order as it moves along from an actual sales order into a work order. Then I will actually show it as it moves into a shipping, and then finally fulfilled with the customer. But along this chain, I'm going to start to look for visibility. What happens if I have something that happens in the middle? In our case, in this example, we're going to look at if there is perhaps bad weather. And is it just an individual order, or perhaps is there more to it? And then more importantly, bring it to the attention of a human. Okay, so in this case, what I'm going to do now is actually come in and let's walk through that. So as we can see over here on the left, we can see that I have my sales order. And now what I've done is it looks like here as I'm looking to ship that, I have a couple of different opportunities to do that. I can ship one here now that's a standard one, and then I can see some cost differences. Now, one of the first things we see in this is an interaction from a visualization that says, well, it looks like perhaps now we are alerting our user that there is perhaps a shortage of a part, which means that this particular one is now increasing the price. And as I step through these kinds of different things, now I'm starting to see that. In the second one then, now I can actually come through and I can say, well, if I chose that option, now I'm giving the human in the loop. Well, because of that, I now can actually see there are some behaviors here, one with the sales bonus, etc. And then as I'm stepping through that, now what I'll do is I can say, well, if I selected this other one via standard, I now actually have a delay, and now I'm going to bring that person in the loop. Well, it looks like perhaps now there is a weather event. Now it looks like this particular order has impacted based on what this weather delay is. But now I want to notify the planner. And in this case, the planner is querying the graph and now realizing, well, no, it's not just one order. It perhaps is impacting now via the Sankey chart, multiple orders, multiple retailers, as well as consumers and corporate. So now the impact or the return on investment in being able to reroute this is now perhaps tens of dollars that has now moved to millions of dollars. And you can see here in the middle, I can start to look in here and say, well, sure enough, there's this weather delay. It shows me what my impact is. And so now I'm looking at time series across the bottom. I'm looking at and using graph to look at what the impacts of those products are, and then perhaps the machine learning, which is now offering to create a plan. In this case, now I'm looking at, well, there is in fact a bit of additional cost, but I can still reroute this for not just this particular package, but for multiple packages. So now what I'm going to do then is let's actually look at what that is. And now I can actually come down and I've applied it. And now I have in fact brought the human in the loop, created the return on investment, which could have perhaps been an impact of millions of dollars. And what I've done now is actually use the system in combination with the graph and the machine learning to actually solve that problem. Okay. So with that, I'm going to throw it to my friend Graham.
Hey everybody, I want to walk through what Scott just talked about in a little bit of technical detail and show you how these things actually happen in practice. So we're going to talk about a few different types of technologies that will allow you to perform those actions you saw in the demo. In this case, we're talking about a suite of methodologies called reinforcement learning, though these are not the only technologies that apply in these cases, and we'll mention a couple other ones later. They are particularly effective, and if there exists enough data to train these algorithms, they can operate at high efficiency and high optimality, as we'll see momentarily. So this is what happens in the reinforcement learning work cycle. You basically train these algorithms on past interactions in your supply chain, external and internal events, which are affecting things going on in your supply chain. And as you update your plans, make, cut, move plans, fulfillment chain plans, etc., you actually retrain the algorithm. So it is adaptable and it is extensible to new situations. There's another note on this slide about embarrassingly parallel training and simulation cycles. All that means is that we can continuously and very efficiently update these models in real time or near real time. So in supply chain, what does this look like? It looks just like this. We have some black box situation on the left-hand side, which we'll describe in the next few slides. But as we work through these work cycles, we're retraining this algorithm. You can see the cycle we have here on the slide, showing that as human beings interact in their daily workflows, we actually build smarter and smarter systems that operate, again, at higher and higher efficiency. And this is what you get from that efficiency. So there are a few bullets on here about efficiency and optimality. the main drive of using reinforcement learning in situations that you can use it in is that it becomes an automated process. Scott talked earlier about the life cycle of these engagements, and how this works in reality is that as the systems learn more and more from interactions with your human planners, they get better and better, and eventually you turn into a fairly hands-off situation where your algorithm is performing most of the work for you. The planning agents in this case basically have three different operational regimes. One is the actual data modeling regime. Therein, we're talking about building up a system to learn from interactions in the supply chain and real-world events. We then deploy these systems on your real scenarios and your real operational plans. And again, the systems learn in real time from interactions with human planners. Those occur obviously through visualization and decision-making workflows, just like the one Scott showed in that previous demo. We have a routing situation here, just like Scott talked about. We're gonna show you a few different methodologies that will solve that problem for you. In all of these cases, it's important to keep in mind that we have several different methodologies operated in real time. So what happens here is that we have a make, cut, move planning scenario, and we want to build an algorithm which will allow us to do both rough cut and fine cut planning when we're operating and before we're operating to make decisions. So we have a planning software on the right that is a Sankey chart showing the fulfillment chain of a big manufacturer. At each one of the nodes in that supply chain, we either make a material through manufacturing, combine that material with some other ingredients, or actually transport that material to, could be an additional manufacturer, could be an end customer. And what we're interested in this one case is the dynamic rerouting Scott talked about a few minutes ago. If we have a situation wherein we're unable to deliver a shipment through certain fulfillment chain channels, we want a system that will automatically reroute that shipment. And you saw the visual output for that earlier. This could be an effect, by the way, of an external weather event, let's say, or it could be, as we're showing on this slide, an internal event like inventory depletion. There are a couple other algorithms here that we can use in tandem with the reinforcement learning operations. These can be used in parallel, like I just showed a few slides ago, where we use multiple systems interacting simultaneously, or they can operate sort of in serial, where we have the reinforcement learning agent actually learn from the traditional techniques. I'm sure in your business, you already have planning software. These systems can learn from the software that you already have in your workplace. These, again, are just another two different algorithm types that we can use to both update and act in concert with your current algorithm types. This is what that looks like in a real world setting. So we have, in this case, a fulfillment chain routing algorithm that we put together for a customer. And these are shipment routes. So these shipment routes are actually optimal as judged by the downtime of the asset deployment. So in this case, we have trucks driving around the United States delivering goods, and these shipments can be picked up and dropped off in a huge variety of terminals. That's because these are retail goods, and they can be you can pick up new goods in the same city that you drop off the current load. In this case, the customer's goal was to optimize the effectiveness of their fulfillment chain by optimally deploying their shipping assets. So if we're driving trucks around empty to pick up new shipments, that is wasting money. And in this case, all you see are these blue colored legs, which means they are all revenue generating legs. This system is obviously now operating at optimal efficiency. That again is using a combination of reinforcement learning and some additional techniques like this one. In this case, we're showing a recommendation of a new shipping route based on the data that we gathered from a customer. And we are using a system in this case called a graph autoencoder to analyze in real time the entire supply chain, the entire fulfillment chain in this United States sector, to plan new routes that would allow our routing engine to operate with higher efficiency. Now, this isn't all about routing. I'm going to turn it back over to Scott for a minute to talk to you about the supply chain as a whole.
Okay. So one of the other things that we want to do now is show a second demonstration. In this case, what we want to do now is actually show, again, that sort of traditional bow tie, which is part of the vocabulary, which is starting to look at what do I do when I want to look at a part, and I want to look at what impacts does it have either to the left, if you will, of the bow tie, which is now perhaps into my source or suppliers, or perhaps looking at it to the right, which is downstream. What happens if I need replacement parts? What happens if things happen? What if predictive analytics has shown me that those parts may fail? Simply, I can start to do things like filtration. And in this example, what I'm doing now is I can look at things by regionality over on the left. I can look at perhaps shortage risks. So show me only sections where shortages are, or perhaps now I care about, in this case, all of the phases. I want to see the entire supply chain from a visibility perspective from source to customer, or I perhaps could turn those off. But as I go through this now I'm looking in this case for an LCD screen. What happens and what are the parts or impact of this particular LCD screen based on this shortage risk? What you can see now is we have some color coding. There are other parts, perhaps these other, whether it's suppliers that are using that screen or other GPU kinds of things that are related. So this is already starting to show me some color coding as it relates to that. But in this case, what I'd like to do now is I'm going to click on this particular screen. Now what I can see is the entire supply chain from sort of source all the way to customer on this particular element. Now, what I've done via machine learning is actually gone out and had it do some color treatment. I can now show that I've got issues in the source section, the inventory section, and in this case, the compliance fitting section. Well, here's my bow tie right here in the center with the compliance fitting with, it looks like parts from an OEM and an assembly that come in. But now what I'd like to do is show me visually. I'm a human, perhaps all of that data doesn't quite make sense to me, but now what I've done is I've shown this Sankey chart, and I can see, sure enough, I look pretty green, even though there are some red sections that are coming in from the source side. Looks like it's tight and there's some constraints in inventory, but it flows along to the assembly. But where I see the big gap now is as I get into this compliance fitting. Now, as I see that, perhaps I actually want to see this in a different way. I now actually want to see more focused wise, where is it in this compliance section, where this particular screen is. And what you can see across the top now is something called time series. I can start to look now at where my demand and production, and I can say, well, sure enough, the demand is quite a bit higher than the production. So indeed, it does look like I have a problem. As I come over now, what I can say is, well, the first sort of 1 degree of separation in the graph is by looking at that relationship. I can see as it looks like there might be a problem here in my North American customer region. As I click on that particular one, what I can say is, well, indeed, that particular sort of customer area for this particular one, I can actually go dive into a little bit deeper. And as I sort of go into what those things are, what I can do now is actually start to get to the next level. And then as I go in, I can say, well, now I've put it into a hierarchy. Now this is a more traditional flow from top to bottom. It comes into this distribution center, and it looks like now I have 3 distribution centers. And in one case, that actually affects all of Europe. So what I'd like to do then is let's come in now. Let's actually go look at the US distribution center. In this case, what I can do is I can actually start to hone in, and I can say, well, what are, before I get in and start trying to solve the problem, let's look at some KPIs. These are, again, things that Graham was talking about, which is perhaps, let's look at some of these trends. It looks like we're actually red at our average transit time. It looks like our service level agreements are trending. but our demand is extremely high, and it looks like, again, we have some issues that we need to address. In this case, now what I've done is I've actually highlighted in this particular set of centers here, I can see that, well, only one of these in the US is green, but the other ones are red. What I'd like to do now is actually smooth those in such a way that take my excess inventory from the US. I'd like to move them to Europe, since the pinch point in my bow tie now is this. I can simply come up here. I can actually click on that and say, I'd like to now rebalance those different inventory sets. And look what I've done now is I've actually rebalanced those. And so in a few mouse clicks, what I've been able to do is identify the bow tie, find the constriction, use the visualization and the machine learning as well as graph to basically highlight that potential issue, and again, save the millions of dollars for losses, potential losses, and then obviously impacts to bad customer perception. Okay, and back to my friend Graham.
So I'll talk a bit here about how that analysis works. Again, the technical details behind the scenes. Scott mentioned the bow tie. This is a common problem in supply chain. I'm sure that this is something you've run into before in your own company. It's very difficult to recognize the bow tie before it happens a priori. And that simply is due to the complexity that exists in all of our supply chains. This is a nice cartoon diagram where we have a throttle point or a choke point in the supply chain. And obviously, it never looks this simple. It looks in reality like this. So we're not going to be able as human beings to tease out those bow tie situations, again, a priori, until we run into some problem, until we have some problem with fulfilling orders to our customers, or until we can't build a make, cut, move plan which satisfies demands on our internal planners. So the question is there anything we could do about this? Obviously, the answer is yes. You just saw that in Scott's demo. And this is how it works in reality. So we use a series of systems. I've mentioned the graph autoencoder here again, and we'll talk about another one in a second. But using graph machine learning based methods, we actually encode all of the information inside of your supply chain, both about the structural characteristics of the supply chain and the inventory characteristics at points in time. Remember, Scott showed you that time bar, that time series slider at the top of the demo. So when we encode both of those pieces of information simultaneously into an analysis using both graph and machine learning, we're able to increase the accuracy of our make, cut, move optimizers and algorithmic planning software with respect to traditional methodologies. So that's what we do at Expero in the supply chain domain. And one of the other things that you can use, that you can do once you have that information is, as I'm showing on this slide, increase the robustness of that supply chain. Make your, let's say in this case, it's a fulfillment chain. This fulfillment chain more robust to failures. So add redundancy into that chain. Another thing we can do with this information, Scott was showing earlier, is analyze in real time the performance of each one of the, in this case, it's facilities in the supply chain, but it doesn't necessarily have to be facilities. It could be something as abstract as a performance characteristic at each region using a so-called unsupervised learning technique. The beauty here is that we don't necessarily have to judge apples against apples. We can, in some cases, judge apples against oranges and grapes and potatoes, and we do that by including many different pieces of information or categories of information into these unsupervised learning techniques. And an example here would be, let's say, gross revenue at each facility. At the same time, simultaneously, you can analyze average worker utilization per some time period. And what you come up with is a stack rank score of each one of the, in this case again, facilities, or let's say regions, or a breakdown inside of the internal supply chain. And it highlights, again, to our end users, and you saw that in the demo, of what actions need to be taken, right? And once the humans have those metrics, they can act on them. This is the actual calculator. This is how this stuff works. This is a neural network. This is a so-called deep learning machine learning system, which analyzes the behavior of your supply chain in real time and outputs predicted metrics as we move forward in time. So we can see here on the left-hand side many different types of unrelated information going into this system, the system in the middle, and the output of production capacity on the right-hand side. So when we would, this is what we just saw in the UI that Scott showed you. We have a red flag maybe that comes up, or a score from 1 to 10 that comes up about the preparedness of our facilities inside of our supply chain, to highlight to our planners and our users inside of our company what is coming up and what needs attention before these things happen in real time. And that's the whole deal here. These techniques allow you to predict what's going to happen before you actually have to go into the reactive case and change your supply chain plans. This is another deeply technical slide on a particular neural network architecture called a long short-term memory network. And this is actually how we enact this system. I encourage you to read up on this if you are a data scientist in your corporation. This is a sophisticated piece of algorithm which is capable of doing some really, really powerful and accurate predictive analytics inside each facility or point of contact inside of your supply chain. Once we have these characteristics at each network node, or let's say again, in this case, we were talking about facilities in Scott's demo, we can actually perform automated intervention analysis using another set of techniques, which is another set of predictive analytics techniques. And we can recommend actions to our users as scored, as stack ranked again, by their total cost to the business. In this case, we're talking about a shortage, a production shortage at this particular facility. These algorithms then look forward in time and recommend actions and give you the costs, anticipated costs of each one of the actions, and rank them. So again, we can expose that to the UI, expose that to the user, and let the humans, keep the humans in the loop and let them make decisions. So you've seen a couple of demos from Scott, and you've seen a couple of behind the scenes algorithms for me. And as you can tell, these machine learning techniques and this graph database world and graph analytics world are only part of the system. You need to include humans in the loop, and we do that through visualization.
Thanks, Graham. So I think that's the core component here, is that simply using graph in addition to your SQL data structure, simply using machine learning in addition to SQL and graph is great. But ultimately, it's that visualization, which is this third leg of the tripod, that sort of get us there. And I think one of the things that people ask us on a daily basis, which is great, let's just build some zippy user interfaces. Let's make it more Sankey friendly. And the answer is, well, there's a lot more to it than that, which is ultimately what we're showing here now, which is the visual design needs to be clutter free. What is it we're trying to share with the user? Let's let them make decisions and or create output or intervene where we need to. And quite frankly, let's not bother the user with information that's noise or quite frankly detracts from what they're trying to do in their day job, if you will. Although some of these screens are cool, let's really try and solve the business problem. Ultimately, that's what we see now is with engineering folks and business users, is that instead of looking at the data model and then building a user interface, let's actually try and do a combination, which is thinking about graph, thinking about machine learning, but more importantly, let's empathetically think about the planner. Let's think about the person on the shop floor. Let's think about the logistics router person. What is it that they are trying to do? Let's use this power and harness now this graph, these other kinds of things, but let's build a great user experience that comes from their view. And that's where we start to see things like we did today, these combination dashboards, this ability to show information that's specific, things that lets them sort of interact, make decisions, whether it's on mobile or not. Perhaps there's a way to boil that down to make decisions only on mobile. This combination of things, in this case, now we see a Sankey chart that brings us information like a combination of the chart and perhaps weather impacts. Many of these are typically geospatial. which is things that are happening in a specific region. Perhaps we want to show heat maps, we want to show time series as we do in the bottom down here, but this combination, what is it that we're trying to use as our focus as we perhaps declutter what it is that our users are trying to visualize. Then we can see dashboards now that perhaps have executive KPIs across the top, and then combinations of products and details, and then perhaps updates that let us jump off into things that we see in choosing our own adventure for what we want to solve in that particular screen. The other kinds of things then is things like logistics, showing us information or impact, or what we see here in some cases we refer to as a blast radius, is if there is, in this case, a port outage or those kinds of things. Give me a visual. How far does this go? What are the things that are perhaps involved? And then we can see standard charts. Deviation doesn't have to be all parts and things. In this case, we see people, and we see different kinds of things like health and safety when it comes to those. And really our goal here, as we've sort of just quite frankly touched the top of all the different kinds of visualizations, we have many of these. And again, your specific use case ultimately drives this kind of visual. But again, the goal then is building something that's useful for that user and ultimately trying to bring it together. Well, after all that, Graham and Scott, now what? This has been exciting. I get it. Graph is interesting. I can use it for supply chain. I think visualization and this combination is really something that I can do. And that's ultimately what we're trying to get to, is trying to solve that business problem for our users, for our management. Let's get that value chain and start to do that. And so what we typically recommend then is this concept, proof of concept, or perhaps a pilot. You may be early in this process. You may have already identified that you want to do these things. And that's ultimately what we like to do here, is take something that's 6 to 8 weeks, try and get something that's focused in these different categories. Let's get these different folks, and many times they indeed are different stakeholders, on the same page. What is it we're trying to do? What are our technology requirements? But what is the impact to the business? And that's what we recommend, is starting to do that. Now, if you are interested, obviously Expero helps customer do these kinds of things, as well as in time frames then that are fairly rapid in the 6 to 8 weeks. And then this is a quick diagram of how we build those. One of the things that we use that you've seen a part of today is part of the Expero solution for supply chain. Many of the screens and the different architecture elements that we've talked about today are part of this toolkit, and this is what we use when we go build these things for our customers. Now, a lot of the open source that are out there today, we can certainly point you in the right direction for different categories of things, whether it's visuals, databases, graph technologies, etc. But this is what we use. And this is kind of how it all hangs together, which is on this backside, whether it's using your legacy SQL and now this combination of graph and NoSQL, plugging it in on top of what you already have is one of the key things that we recommend. And then ultimately now, let's get it in front of users. Let's get their real-time feedback. Let's get their input on how this system is going to work. And many times what we do in these prototypes is identify, perhaps we've come close, but we've not hit the mark exactly. The users are always the first ones to let us know how close or how good it really is when we do those. But again, this is no different than any other agile sprint. It's just that we're doing this now with new technologies. Okay, and with that, we come to a close, and back to Ashley.
Awesome. Thank you, Scott. Thank you, Graham. Just a reminder, you can submit your questions in the Q&A box at the bottom, and we will work our way through those. To start out, we have a question here about proof of concepts, Scott. What are different types, and what's the time frame on those?
Great question. If there's any other questions out there, make sure you send them along. But the different types of proof of concepts that we've seen are anything from a technology proof of concept that Graham has done many times, which is doing things perhaps non-visually, making recommendations or routing real time, or perhaps simple notifications in existing user interfaces, all the way out to a full visual user interface in a dashboard for a planner, which was one of the ones that we showed today. And that these prototypes don't necessarily take on visual aspects all the time, but they can.
Awesome. Another one here says, what are some good references for different technologies?
So we talked today about a wide variety of technologies. If you go back and rewind back through the recording of this webinar, you can see the link that we had to our personal page linking a bunch of graph and machine learning technologies. Alternatively, or additionally, you can look up some machine learning resources, and there's one in particular that's brand new that we've been having a lot of success with, and that's DeepMinds. That's a Google Groups. New research on so-called GraphNet. So if you look up DeepMind graph_net, you'll find some really key resources there.
Thanks, Graham. And also, Expero has several blogs on different technologies that you can check out. I will send a link for that, as well as the things that Graham mentioned in the follow-up email. I do have a question about sharing the presentation, and yes, we will be sharing the presentation as well as this recording and all the links mentioned in today's seminar. If you happen to have any follow-up questions, you can just hit the reply button and we will get back to you on those, and you should see that later today. I have another question here that says your tool is like ERP, has all the modules like forecasting, replenishment, warehouse, and transportation, and the real-time calculations on these data elements showing the output in graphs, recommending the users. Is my understanding correct? What is the database tool you are using?
Well, that's quite a complicated question, a couple of different layers. The first element is no, we are a consulting company here at Expero. This is part of our toolkit, meaning this is one of the tools that we use. We build it in React, typically, or Angular. It sits on top of the current data set. So if you're using an SAP, we actually then plug that in so that we can start to do this analysis or visualization. And it can actually sit inside of other dashboards or other kinds of things. And then from a technology or database tool, we are agnostic. And so in certain solutions, we have used Google toolkits. We have used AWS, Dynamo, those kinds of things, many other technologies that are out there. When we look at the graph technology, we look at many different types of technology for graph. Janus Graph is an open source. We use DataStax, Neo4j, many of the other providers that are out there, et cetera. And so because we are indeed agnostic, many of these different technologies can work together. And that is part of what we provide here at Expero is recommendations on which work better together. And perhaps if you're using an Oracle or an SAP, which ones have adapters, which are self-sufficient and more open source versus closed. And so that's a very long answer to, we look at different technologies depending on our customers.
Cool. Thanks, Scott. I have one more question here, and that is, where can I find your demos?
Yes, so many of the demos that you saw today are actually conveniently located on the Expero website. Under resources, you'll see a demo library, and you can go out and actually peruse all of those. And if you enjoyed my voice today, you'll hear it many times in many of those demonstrations.
Great. Well, thank you so much, everyone, for joining us. Again, this will all be sent out to you. And if you have any questions, you can just click the reply button on that email. Appreciate you spending your afternoon with us. Hope you have a great day.